Okay, as I said the other time, getting started on balancing chemical equations can be a little bit tricky. So in this exercise, I had you working on this online chemical balancer up here at the top. You click on the link and it'll take you to here. I put an ad blocker on this because there's a lot of pop-ups. But we're going to look at this, and one of the nice things this does is if you start off by putting one coefficient in for everything, it shows you a picture of what the molecule looks like. So we have this elemental iron over here, and we have this elemental sulfur, and then we have this iron sulfide, and you can see that there's one iron hooked to the sulfur. So if we actually look, there's on this reactant side of the arrow, there's one iron and one oxygen, and over here there's one sulfur and one iron and one sulfur. So that looks balanced. And it does say that it is balanced. So our coefficients over here, we're going to on our worksheet, 1, 1, and 1. Okay. On this next one, like I said, it helps if you put in the 1 coefficients for everything first. It makes it a little easier to count. And you can see in this diatomic hydrogen, we have 2 hydrogens. In the diatomic chlorine, we have 2 chlorines. And over here in this compound, the HCl, we have 1 hydrogen and 1 chlorine. So we need to bump this coefficient up. When we do that, we're making 2 of these compounds. Now in the product side, we have 2 hydrogens and 2 chlorines. On the reactant side, we have 2 of each as well. So that is balanced. So our coefficients are 1, 1, 2. Okay, so like I said, it helps if you put in the 1 coefficients for everything first. When we look over here, we have 1 magnesium, the diatomic oxygen, 2 oxygens, 1 magnesium, and an oxygen. So there's more oxygen on this side than on this side, so we've got to bump this coefficient up to 2. When we do that, on the product side, we have 2 oxygens, and now we have 2 magnesiums because we're making 2 of this whole magnesium oxide. Over here, it's good with the oxygens. We need to bump this up to 2 magnesiums. Now this looks balanced, so I'm going to put this in on my worksheet. 1, 2. And it says we're correct, so we'll go to the next one. Okay, now in this next one, we're going to put in the 1 coefficients for everything to get started so we can see the molecules. Diatomic oxygen, there's 2 oxygens. Diatomic hydrogen, there's 2 hydrogens. In the water molecule, there's 2 hydrogens and an oxygen. There's more oxygen over here on the product side than there on the reactant side. I need to bump this coefficient up to a 2. When I do that, I see that there's 2 oxygens over here and 2 oxygens over here, but there's 4 hydrogens over here now. So I need to bump this up to a 2. Now there's 4 hydrogens on this side, 4 on this side, 2 oxygen, 2 oxygen. So this looks balanced. Put this in over here. We need to check. It says we're correct. So we'll go to the next one. Helps if you put in the 1 coefficients. Okay. So you've got in this compound, in the mercury oxide, we have an Hg and an O. Over here we have 1 Hg, but we got 2 O's. So I'm going to have to bump this up to a 2 to get more oxygens over here on the reactant side. We got 2 oxygens and 2 oxygens, 2 mercuries, but only 1. So I'm going to bump this up to a 2, and now I have 2 mercuries, 2 mercuries. On the reactant side, 2 oxygen, 2 oxygen. So this looks balanced. And it says we're correct. As I said, start out by putting in the 1 coefficient for everything. I like this one because it shows us we have 1 calcium. In the water, we have 2 hydrogens and oxygen. And in this compound here, we have 1 calcium. Remember, the 2 on the outside of the parentheses means there's 2 of these hydroxides. And in this diatomic hydrogen over here, there's 2 hydrogens. So we check, we've got 1 calcium here, 1 calcium here. Over here, however, we have 4 hydrogens and only 2 over here. So I'm going to bump this up to a 2 to get some more hydrogen on the reactant side. Now I have 1, 2, 3, 4 hydrogens over here. I have 1, 2, 3, 4 over here. I still have the 1 calcium. Over here we have 2 oxygens, and over here we have 2 oxygens. So it looks like this is balanced. So I'm going to go ahead and put this into my worksheet. 1, 2, 1, 1. Check, do this a check. It says we're correct. So we'll move to the next one. As I say, it helps if you put in the 1 coefficients for everything when you get started. Okay, so over here on the reactant side, we have 4 hydrogens and a carbon. And the oxygen, we have 2 oxygens. And in this carbon dioxide, we have 1 carbon and 2 oxygens. And in the water, we have 2 hydrogens plus 1 oxygen. So I can see that there's 4 hydrogens over here, and only 2 over here. So I'm going to bump this up to get some more hydrogen on the product side. So I got 4 hydrogens here, 4 hydrogens here, and 1 on this side, I have 1 carbon, and on this side, I have 1 carbon. On this side, I have 2 oxygens. On the product side, I have 1, 2, 3, 4 oxygens. So I need some more oxygen over here. So I'm going to try a 2 coefficient there. I'm going to check everything. 1 carbon, 1 carbon. 4 hydrogens, 4 hydrogens. 4 oxygens, 4 oxygens. So this looks balanced. So I'm going to put this in my worksheet. 1, 2, 1, 2. And we're going to check for balance. It says we're correct. That pops us up to the next one. Okay. So it says we have this sodium oxide. We have 2 oxygen, 2 sodiums in that molecule. We have 2 hydrogens, and we have this SO4. We have 2 sodiums in SO4, 2 hydrogens in this peroxide, and 2 oxygens. So let's start. We got 2 sodiums here and 2 sodiums here. So the sodium looks good. Here we have 2 oxygens plus 4 oxygens over here. And we have 4 and 2. So the oxygens look good. The hydrogens, we have 2 over here. We have 2 over here. So that looks good. On this next one, like I said, put in the 1 coefficient for everything. And this diatomic nitrogen, this diatomic hydrogen, and this H, and then we have this NH3. Now, one of the tricks here is I see that the hydrogens are in groups of 3 here and groups of 2 here. So I need to think really about a common multiple. So I'm going to try a 3 here and a 2 here so I can get the hydrogens and bonds. I have 2, 4, 6 hydrogens. And I have 3 plus 3 is 6. And I have 2 nitrogens. And I have 2 nitrogens. So this looks like it's balanced. And as I said, start off with 1 coefficient in all the boxes so you can see a picture of the molecules. Over here I have 1 aluminum, 2 oxygens, 3 oxygens here, and 2 aluminums. So again, I'm looking at this subscript. I've got a group of 3 and a group of 2. So the only way to get these oxygens in balance is to try a common multiple. So I'm going to make this a 3 and this a 2. Okay, because 2 times 3 is 6 and 3 times 2 is 6. So now I have 2, 4, 6 oxygens. I have 1, 2, 3, 4, 5, 6 oxygens. I have 1, 2, 3, 4 aluminums. I need to bump this up to a 4. It's more over here. Now it looks like everything's in balance. Like I said, start off by putting in the 1 coefficient for everything so we can see pictures of the molecules. Okay, so over here, I have 4 oxygens in this, manganese, and this potassium. And then it's going to yield this potassium oxide with 2 potassiums and an oxygen, this magnesium oxide with 1 magnesium and oxygen, and this diatomic oxygen. Okay. Well, right off the bat, I see I have 1 potassium over here, and I have 2 over here. So I got to bump this up to a 2. And now I see I have 2 manganese over here. Now we have 1 manganese over here. So I need to bump this up to a 2. So then I have 2, 4 oxygens, and I have 2, 4 oxygens. And over here, I have a problem because I have 1 oxygen here and 2 here, a group of 2. So I'm going to have to do something with this because I need to make this an even number because this is always an even number. So I'm going to have to bump this up to a 2. So I have 2 oxygens and 2 oxygens, so I have 4. So this is an even number. Now I've messed up these potassiums. So I'm going to have to make this a 4. Okay? So I have 4 potassiums now and 4 potassiums on the product side. I have 1, 2, 3, 4 manganese. I only have 2 here, so I'm going to have to bump this to a 4. Okay, and on the product side, I have, on the reactant side, I have 4 plus 4 is 8, plus 4 is 12, plus 4 is 16 oxygens. Over here I have 1, 2, 3, 4, 5, 6 oxygens. So I need to get to 14. So I think make this an 8. That should be good. 2, 4, 6, 8, 10. Make this a 4. 2, 4, 6, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I have 10, 11, 12, 13, 14, 15, 16. So that looks balanced. I'm going to write this down. 4. I can always change this if we have to go back and adjust. Let's check to see if it's balanced. It is balanced, so we're good. Okay, so we have to do these ones down here, and this is more like what you'll typically see on quiz or homework assignments. So first we're going to start off by counting the elements on both sides. We have 1 sodium. In the water and the H2O, we have 2 hydrogens and 1 oxygen. We're going to look over on this side, and we have 1 sodium. We have in this OH 1 hydrogen, 1 oxygen, and then we have 2 more hydrogens there, so we have a total of 3. Now, so we kind of have to think like the oxygen over here, I'm sorry, the hydrogen over here is, we have an odd number of hydrogens, and over here in H2, it only comes as an even number. So I want to try and fix this first. I'm going to put a 2 in front of this whole formula. When I do that, that makes this 2 sodiums, and now I have 2 hydrogens plus these 2 is I have a total of 4 hydrogens, and I still have, 2 oxygens. Okay, so I look over here, now it's not in balance for the hydrogen and oxygen. I need twice as much hydrogen, twice as much oxygen. So I think I can fix that by putting a 2 here. When I do that, 2 times 2 is 4 hydrogens, and 2 times 1 is 2 oxygens. Then I see that the sodium is still out of balance, so I need to put a 2 prefix here. Since it's a single element, that one's easy to fix. That makes this a 2. Okay, and then this looks like it's in balance. Put a 1 here. Okay, now over here, I have 2 hydrogens. I have 1 SO4. I have 1 sodium. And then I have 1 oxygen. And I have 1 more hydrogen. Okay. Over here, I have 2 sodiums, Na2. I have 1 SO4. And in the water molecule, I have 2 hydrogens and 1 oxygen. Again, I see a problem here. I have hydrogen is only in even numbers over here, and I have an odd number over here, so I need to get this to be an even number. It's never going to be able to be a multiple of this. So I'm going to put a 2 here. And when I do that, I have these 2 hydrogens, plus now there's 2 of these, so I have 4 hydrogens, and in here I have 2 oxygens. And this also means that I have 2 sodiums. Okay. Now I see that I have 2 hydrogens and 1 oxygen, and I should have 4 and 2, so half as much over here is what I need. So if I put a 2 coefficient in front of the waters, I have 4 hydrogens and 2 oxygens, and it looks like I'm balanced. So 1 coefficient for each of these. We'll finish, and it looks like I got this right. Welcome back. We're going to work on balancing this page. So first thing we're going to do is count the atoms of each element as a reactant and then as a product. So I have 1 mercury, 1 oxygen. Here I have 1 mercury and I have 2 oxygens. So I see that I haven't got enough oxygen on the product side, so I'm going to try a 2 here. If I do that, that makes this a 2, makes this a 2. Okay, and now I see that I don't have enough mercury up here. I'm going to put in a 2 and a 1, makes this a 2, and it's balanced. Okay, over here I have 1 silicone, 2 chlorines, 1 silicone, and 4 chlorines in that formula. I see that I haven't got enough chlorine over here, so I'm going to bump this up to a 2 coefficient. When I do that, it makes this a 4, and now it's balanced. Okay, this is one of those deals where you got to find a common multiple, because oxygen is in a group of 3 here and a group of 2 here. The common multiple between 3 and 2 is 6, so I'm going to put a 2 here and a 3 here. When I do that, 2 times 3 is 6 oxygens, and 3 times 2 is 6 oxygens, so that's the balance. Okay, in this formula, there's 1 potassium, 1 chlorine, and 3 oxygens. Over here in this formula, there's 1 potassium, 1 chlorine, and 2 oxygens. Again, I see this grouping of 2 and 3, so I need to find a common multiple to get this oxygen in balance. So I'm going to put a 2 here. When I do that, that makes 2 chlorine, 2 potassiums, 2 chlorines, and 2 times 3 is 6 oxygens. Okay, and I see I need to put 3 here. That makes 6 oxygens here. And then I see that I only have half as much potassium and chlorine as I need. So I'm going to try a 2 coefficient here. When I do that, that bumps these both up to 2, and now we're in balance. And this next one, okay, right off the bat, I can see that I have a group of 3 here and a group of 2 here. So I'm just going to start off by putting a 3 here and a 2 here to find that common multiple. And now I'm going to count. I have 1 iron. 3 times 2 is 6 oxygens. And then 2 times 2 is 4 irons. And 2 times 3 is 6 oxygens. So I see I have 4 irons on the product side and only 1 iron on the side. I'm going to put 4 coefficient here. When I do that, that makes this a 4, and everything is balanced. Okay, here I have 2 hydrogens, 2 oxygens, 2 hydrogens, and 1 oxygen. So I need more oxygen over here. The only way I can increase this is to make more water molecules. I'm going to put a 2 in front of the water. When I do that, that means I have 4 hydrogens and 2 oxygens. Okay, that the oxygen is balanced, but I only have half as much hydrogen on the reactant side. I'm going to put a 2 here. 2 times 2 is 4, and now we're balanced. Okay, I'm going to put a one coefficient there. Okay, on this one, already I can see I have 2 chlorines here and only 1 here. So I'm just going to start off by putting a 2 coefficient there. So I have 1 sodium, 2 chlorines, and I have 2 sodiums and 2 chlorines. I see that the sodium is not in balance. I need to try a 2 coefficient here. I do that, and that makes this a 2, and we're using only 1 Cl2. Okay. In this equation, I have 1 aluminum. Here I have 2 hydrogens, and there's 1 SO4. Over here in the Al2, I have 2 aluminums, and it says there are 3 SO4s, a little subscript, and then there are 2 hydrogens. Okay, so I don't have enough SO4s over here. Okay, the only way I can do this is to put 3 here. When I do that, 3 times 2 is 6 hydrogens, and then 3 SO4s is 3. And then, sometimes you fix one thing, you fix something else. I have 6 hydrogens here and only 2 here, so I'm going to put a 3 here. 3 times 2 is 6. Okay, so now I've got the sulfate is balanced, the hydrogen is balanced. I have 2 aluminums on this side, but only 1 on this side, so I'm going to bump this up to a 2 coefficient, and we're using a 1 there. I bump this up to a 2, that means this is a 2, and everything that goes in is equal to what comes out. Okay, and on this one, you have 1 nickel, you have 2 NO3s, you have 1 sodium, and 1 OH. Over here, I have 1 nickel, I have 2 OHs, I have 1 sodium, and 1 NO3. So I see that the NO3s are not in balance. I have 2 on the reactant side and 1 on the product side. I'm going to put a 2 here. When I do that, that makes 2 sodiums, and it also makes 2 NO3s. Now I look over here, and I see that I don't have enough NaOH. I have half as much as I need. So I'm going to try a 2 coefficient here. When I do that, that means there's 2 sodiums and there's 2 OHs. Now it looks like I'm in balance. So I'm going to put a 1 here, 1 here, and I'm going to finish. So we'll pick up here. We'll pick up next time, and I hope you're having a great day.